I'm Elizabeth Yasin, and thanks Mr. Chairman for giving me the opportunity to present my paper in this session. The title of my paper is MSD Conjugate Free Convection Flow from an isothermal vegetable cylinder with stress 1. This is the abstract of my paper. In this paper, effect of conduction and stress 1 on magnetohydrodynamic free convection flow from an isothermal horizontal circular cylinder along the outer surface of the lower specification point to the upper specification point are investigated. The developed governing equations are made non-dimensional by using a suitable transformation. Then the non-dimensional equations are solved by implicit finite difference method with surface. Numerical outcomes are found for the different values of magnetic parameter, stress work parameter, and conjugate conduction parameter. And the results, for the velocity, temperature, distribution, stimulation, and the heat transfer are presented graphically. Is a complete system. This is the layout of the presentation. First of all, we did discuss the formulation of the problem, then methods of solution, then results and discussion, and finally conclusion. Objective of the present work will investigate the effect of reversing conjugate free convection flow from an isothermal horizontal circular cylinder with stress 1 to transform the governing equations into a non-dimensional form using simulatory technique to solve the dimensionless equations numerically by finite difference method. To compare the results of the study with the relevant work like Martin and Nazari here. Mathematical analysis. We consider a steady free convection flow of viscous incompressible electrically conducting fluid from an isothermal horizontal circular cylinder. Here we consider a uniform temperature infinity of the fluid, and TB is the core region with temperature TB, and the uniform magnetic strength V0 acting normal to the cylinder, and the thickness of the cylinder considered is that is V. X bar is the X bar axis is the along the circumference of the cylinder, and Y bar axis is normal to the cylinder. And these are the governing equations for the present problem. And in this governing equations, this is body force. We considered Gaussian approximation in this body force. This is magnetic field resistance term and stress work term. First equation is the continuity equation. Second one is the momentum equation, and third equation is the energy equation for this problem. This is the boundary conditions. On the surface, the velocities are 0, and we consider the surface temperature here, and this is the condition for conjugate heat transfer, that means conduction from the cylinder to the outside. And at the infinity velocity and temperature is the temperature of the surrounding. Non-dimensional, we consider these quantities to non-dimensional our equation, and here we use Grashof number, which is acid large for free convection. Using these quantities, we obtain two non-dimensional forms of the governing equation, and in this equation we get three parameters. The first parameter, that is m, equals to magnetic parameter, and the second one is the stress work parameter, and third one is the Kondo number. Using the non-dimensional quantities, the boundary conditions is like this one, and here we get another parameter T. T is the conjugate conduction parameter, and in this parameter we observe that P depends on the ratios of V by L, Kf by Ks, and the Grashof number, and here V by L is and Kf by Ks is less than 1 and Grashof number is last of T conversion, so that the value of T is greater than 0, and in case of D is equal to 0, we can assume T is equal to 0. To solve the equations, we consider a stream function, and using this stream function, we know that this stream function defined as this equation is like equation 11, and using this stream function, we get the new form of the governing equations like equation 12 and 13. Equation 12 is the dimensionless momentum equation, and equation 13 is the dimensionless energy equation with stream function. In these equations, prime means that the differentiation with respect to what, and the corresponding boundary condition using stream function like equation 14, and the principal physical quantities, the sharing stress and the Nusselt number like equation 15 and 16, and using this equation we calculate the excitation coefficient and heat transfer, and from equation 17 we calculate the velocity profile and temperature distribution in the boundary layer. This is the method of solution. In this, to solve these equations numerically, we use finite difference method with curve of system. Results and discussion. For the whole simulation, we consider Kondo number equals to 1, and first of all, we compare the present result and the previous result like and all is here. And this is the present result for the Nusselt number, and this is the present result for the expectation. And comparing with Martin and Nozzle, we observe that there is an excellent agreement of the present results with the previous result. Now we discuss the density profile and temperature distribution for different values of magnetic parameter, and from these two figures we observe that the velocity decreases but the temperature increases for increasing values of magnetic parameter. This is due to we know that magnetic parameters work against the flow, and due to interaction between the magnetic field and the flow field, temperature increases. Since the velocity decreases with the increasing magnetic parameter, it decreases the inflation, and increasing temperature within the boundary layer make a difference, temperature difference between the from the surface to the outside, and ultimately it decreases heat transfer from the surface to the cylinder, from the surface to the outside of the lid. This is the velocity profile and temperature profile for different values of stress work parameter, and from this two figure we observe that velocity decreases, but temperature, velocity and temperature both decreases with increasing stress work parameter. And we know that the stress work parameter containing gravitational force and which against the buoyancy force, as a result motion of the fluid decreases, and we observe this from figure 6. This is the distribution and heat transfer effect for different